Dear children, today we'll discuss about a very important topic, that is dimension of physical quantities. What do you mean by dimension? For example, the dimension of this room is 20 feet cross 15 feet cross 10 feet. The dimension of this room is 20 feet cross 15 feet cross 10 feet. That means the length of the room is 20 feet, the breadth of the room is 15 feet, and height of the room is 10 feet. That means from the dimension, without seeing this room, we can have proper knowledge about the room. What is the length, what is the breadth of the room, what is the height of the room. Now, in the same way, we have 7 fundamental quantities and there are lots of derived quantities. That means all the physical quantities can be expressed in terms of these 7 fundamental quantities. So from the dimension, we can know which fundamental quantities and how the fundamental quantities are used to represent the physical quantity completely. So from dimension, we can know which and how the base quantities or the fundamental quantities are used to represent the physical quantity completely. So you remember, what do you mean by dimensions of a physical quantity? You remember the dimensions of physical quantity, the dimensions, repeating again, the dimensions of a physical quantity are the powers or the exponents must be raised to the base quantities to represent the physical quantity completely. Again, what do you mean by dimensions of a physical quantity? The dimensions of a physical quantity are the powers or the exponents to which fundamental quantities or base quantities must be raised in order to represent the physical quantity completely. These powers are the dimensions. For example, you take force. Force is mass into acceleration. That is mass, acceleration, that is change in velocity by time. It is your mass, change in velocity, that is displacement traveled by time taken. That means displacement by time divided by time. It is your mass, displacement, that is your length, You see, divided by time, again the denominator you have time, that is 1 by time square, that equal to mass to the power 1, length to the power 1, time to the power minus 2. The dimensions of force are the powers of the base quantities. So the dimensions are 1, 1 and minus 2 in terms of mass, length and time respectively. That means dimensions of force are 1 in mass, 1 in length and minus 2 in time. And you remember, the dimensions are represented by square brackets. They are represented by square bracket. Force square bracket means it is asked about the dimensions of force. So you see the expression here, mass, length, time. Instead of writing the whole word mass, length and time, we can use the symbols. Capital M for mass and length, capital M for length and capital T for time. Not only you have these 3 fundamental quantities, you have 7 fundamental quantities, you have other 4 fundamental quantities. So we have to use the symbols for all these 7 fundamental quantities to represent dimension. Now come to symbols for 7 fundamental quantities to represent dimensions. Mass dimension, that is M, and you remember dimensions are represented in terms of square brackets. Then length, that is L, time, that is T, current, that is electric current, that is A, temperature, that is K, capital M, capital L, capital T, capital A and capital K. Now luminous intensity, that is your small c small t in the square bracket. Then amount of substance, that is MOL square bracket. So these are the symbols. Instead of using the whole word, we can use the symbols. Now come to dimensions of some physical quantities. For example, area. The dimension will be, the formula is length into breadth. Length, that is L, and breadth, that itself length, so it is L2. Here you have no mass and time. So if you want to write mass and time, then mass power is 0, L power here 2, T power is 0. So the dimensions are 0 to 0 in terms of mass, length and time respectively. Or you can say it directly the dimensions of area, that is 2 in length. If you want to write mass and time, then power will be 0, because 0 power 0 means here it has no mass and no time. So now come to volume. Volume dimension. It is, length into breadth into height. For length it is L, and for breadth it is L, and height it also the length, so it is L, that is L cube. That is, here it has no mass and time. If you want to write in terms of mass, length and time, then it is M0, L3, T0. The dimensions are 0, 3, 0 in terms of mass, length and time respectively. You remember the powers are the dimensions, and the whole square bracket is the dimensional formula. The whole square bracket is the dimensional formula. What is dimensional formula? It is the expression which represents which fundamental quantities and how the fundamental quantities are used to represent the dimensions of the physical quantity. That means, in very simple, the whole square bracket is called as dimensional formula, and the powers are called as dimensions of the physical quantity in these base quantities. Now come to speed. Speed, distance traveled by time taken. So dimensions of speed, for distance it is L, and for time it is T. So it is L1 T minus 1. If you write mass, M0 L1 T minus 1. That means the dimensions are 0, 1, minus 1 in terms of mass, length and time respectively. Similarly, velocity, that is displacement by time, or displacement it is L, time T, that is L1 T minus 1, so it is M0 L1 T minus 1. It is the dimensional formula, and the dimensions are 0, 1, minus 1 in terms of mass, length and time respectively. Now come to acceleration. Acceleration that is acceleration change in velocity divided by time. Therefore acceleration dimension, velocity dimension is L1 t minus 1, means change in dimension, change in velocity has the same dimension as that of velocity. So it is L1 t minus 1 divided by time, that is t. So it is L1 t minus 2. And in terms of mass, length and time, it is m0 L1 t minus 2. It is the dimensional formula of acceleration, and the dimensions are 0, 1, minus 2 in terms of mass, length and time respectively. Now force you know, it is mass into acceleration. Force dimension, it is mass dimension into acceleration dimension. Mass dimension m1 and acceleration dimension L1 t minus 2. So it is m1 L1 t minus 2. It is the dimensional formula of force, and the dimensions are 1, 1, minus 2, 1, 1, minus 2 in terms of mass, length and time respectively. Similarly, you say pressure dimension, you know, that is force dimension divided by area dimension. Force dimension, that is you just obtained, that is m1 L1 t minus 2 divided by area, that is L2, that is m1 L minus 1 t minus 2. It is the dimensional formula, and the dimensions are 1 minus 1 minus 2 in terms of mass, length and time respectively. Now come to work dimension, that is force dimension into displacement dimension. Force m1 L1 t minus 2, displacement itself like that is L1, so it is m1 L2 t minus 2. It is the dimensional formula of work, and the dimensions are 1, 2, minus 2 in terms of mass, length and time respectively. Similarly, you can find for power dimension, that is work dimension divided by time dimension. Work m1 L2 t minus 2 by time, that is m1 L2 t minus 3. The dimensional formula is this, and dimensions are 1, 2, minus 3 in terms of mass, length and time respectively. Now come to angle. Angle, you remember, it is dimensionless, that is m0 L0 t0. Angular displacement, that is the angle itself, it has no dimension. It is m0 L0 t0. It is dimensionless. All are zeros means it is dimensionless. Angular velocity, it is angular displacement divided by time. Angular displacement, that is m0 L0 t0, and time is t, so it is m0 L0 t minus 1. So the dimensions are 0, 0, minus 1 in terms of mass, length and time respectively. Similarly, electric charge. that is electric current into time. So electric charge for electric current it is A and for time it is T. So it is A1 T1. That means it is dimensions are 1 1 in terms of current and time respectively. These are the dimensions we have discussed, dimensions of some physical quantities. Gradually you will learn dimensions of all the physical quantities. In the next class we will learn about uses of dimensional analysis.